Good morning, everybody. Today we're covering Unit 1, Lesson 2, Factoring Polynomial Expressions. So factoring is something that you would have seen in grade 10 and grade 11. We're just going to spend today kind of reviewing the different methods you've learned of factoring in the past. So just some things to remember about factoring. Factoring is the opposite of expanding. So when we factor, we're basically undoing any expanding that we already did. So if you think about opposite operations like multiplication and division or addition and subtraction, they're opposite of each other. Okay, the same can be said about factoring and expanding. When we have an expression in factored form and we expand it, we're essentially carrying out the multiplication. When we have an expression in standard form and we want to get it back to its roots or its factors, we factor it to do that. So they're just undoing each other. So the first type of factoring we're going to talk about is common factoring. So common factoring, we want to take the greatest common factor and we're going to pull it out of the expression. So the greatest common factor is the largest number and or variable that is a factor of each term in a polynomial expression. So the process for common factoring is that we're going to remove the greatest common factor, or the GCF, as the first factor, and then we will divide each term by the GCF, by the greatest common factor, to obtain our second factor, and that'll be written in brackets. So we'll just say written in brackets. So our first example here, so we have 8x squared y to the power of 3 minus 12x to the power of 4y. So if we want to try to common factor that, we have to look at our coefficients and our variables. So our greatest common factor of our coefficients, 8 and 12, you know, think about the factors of 8 and 12 and which one is the biggest that they have in common, is going to be 4. When we take a look at our variables, the rule for the variables is that we're always going to factor out the variable with the lowest exponent. So for each variable, which one has the lowest exponent? So my x's, I have an x to the power of 2 and I have an x to the power of 4. So I can pull an x to the power of 2 out of both of those. That'll divide evenly into both of them. For my y, I have y to the power of 3 and y to the power of 1. So I can only take a y to the power of 1, right? Because I can't take y to the power of 3 out of my y to the power of 1. So I can only take out a y to the power of 1. Okay, so we're going to rewrite this equation, or expression. We have 8x squared y to the power of 3 minus 12x 4y. We're going to divide each of these terms by my greatest common factor. So my greatest common factor was 4x squared y. We'll divide both of those by that. We have to think back to our exponent rules a little bit here, but first let's write. So it says we remove the greatest common factor, and that's going to become our first factor. So we'll write that in our next step. So we'll have 4x squared y. Now we have to carry out all this division that we've created. So we have 8x squared y to the power of 3 divided by 4x squared y to the power of 1. So we'll start by dividing our coefficients. So if we divide 8 divided by 4, that'll just be 2. When we get to our variables, we have to remember our exponent law. So I'm going to just make a little side note over here. Remember that if we have two variables with the same base and we divide them, we have to remember, what do we do with their exponents? So yesterday we talked about we add their exponents when we multiply. When we divide them, we're going to subtract their exponents. So a to the power of m divided by a to the power n is going to result in a to the power of m minus n. So when I look at my x's, when I divide them, I'm going to subtract their exponents. So x to the power of 2 divided by x to the power of 2 is going to be x to the power of 0. So we'll keep that in mind when we go ahead and divide our y's. We have y to the power of 3 divided by y to the power of 1. So y to the power of 3 divided by y to the power of 1 is going to be y, and then we subtract those exponents, so y to the power of 2. Come over here and do that with the other division. So 12 divided by 4 is 3, and then x to the power of 4 divided by x to the power of 2 is going to be x to the power of 2, and then our y's both have 1's on them, so y to the power of 1 divided by y to the power of 1 is going to be 0. So we're just going to simplify this. Remember, put another exponent law up here, that any exponent to the power of 0, or any variable to the power of 0, is just going to be 1. So when I have x to the power of 0, that just cancels itself out to 1. So let's simplify this. 4x squared y. That's going to become 2, and then my x is gone now. y2 minus 3 x2, and then that y is gone. Okay, so that is the original expression in factored form. So pause the video now and go ahead and try to factor that second example. So there's your solution for the second example. We pulled out, or we factored out a 6x. We'll take a look at group factoring now. So when we're factored by grouping, we're going to take some terms and we're going to group them and just factor from that group of the expression. So we're not factoring from the entire expression, but just a group of terms. So factor groups of 2 terms with a common factor to produce a binomial common factor. So when we do that, after we common factor by grouping, then we're going to remove the binomial common factor, and I'll show you what I mean. So remove the binomial common factor. Just make sure we're up in the viewing window. Okay, so if we take a look at our first example here, we have bx plus 3x plus by plus 3y. So hopefully we can start to look at these expressions and see what things I could group together that might have something in common that we could factor out. So if I take my first 2 terms, when I look at those, I see, okay, they both have an x in those terms, so maybe I can common factor that out. If I look at grouping the second 2 terms together, those both have a y in them that I can common factor. I'm going to start by common factoring out of this first grouping. So bx and 3x, I'm going to common factor out an x. Okay, but when I common factor out an x from here, actually let's write this like this. I'm going to take an x out of this first group. So let's divide everything by x. Okay, now I'll have an x out front. And bx divided by x, well, those x's just cancel out, and we're left with b. 3x divided by x, again, those x's cancel out, and we're left with 3. I'm going to do the same thing with the second 2 terms. So if I take by plus 3y, the common factor here we said was y. We can divide by everything. So I'm going to write that common factor out front of this bracket now, because that is the common factor being pulled out. And then inside the division, or inside the brackets, we'll do all this division. So by divided by y, those y's will cancel, and you're left with b. Then if we have 3y divided by y, those y's cancel, and we're left with b again. Now if we look at this expression we've created, if we look at x times b plus 3 as one term, and this y times b plus 3 as another term, we can see that we have a common binomial here, right? A binomial is 2 terms inside of a bracket. So we're going to factor out our common binomial. So we're going to factor our common binomial, which is, in this case, is b plus 3, right? We can see the bracketed piece is what's common to both of these. So I'm going to rewrite this step. Oops. I'm going to rewrite this equation, and this time I'm going to divide each of my terms by b plus 3. Okay, so because I'm dividing by that, that's my common factor. That's what I'm going to pull out front, is that b plus 3 that I'm dividing everything by. And then inside my other bracket is going to be the result of this division. So if I do x times b plus 3 divided by b plus 3, those b plus 3's cancel out, and you're just left with x. Over here, y times b plus 3 divided by b plus 3, those b plus 3's cancel out, and you're left with just y. Okay, so when you factor by grouping, you'll end up with a binomial times a binomial. Go ahead and pause the video and try to do that second example. Okay, so here's the solution for the second one. We grouped the 6x squared minus 2x, and then we common factored out our 2x from the first two terms. And then the second group, we put 15x and 5 to get minus 5 together, and we common factored out a 5. Okay, once we pulled those things out, we were left with this common bracket of 3x minus 1. So we divided both of our groupings by 3x minus 1. And when we do that, the 3x minus 1's cancel out. And so you're left with 2x. And then 3x minus 1's cancel out, and you're left with the plus 5. Okay, we'll go to the next. Okay, so another method of factoring you would have used in the past is simple trinomial factoring. So when we have a trinomial, meaning we have three terms, we have ax squared plus bx plus c, so 1, 2, 3 terms, and our a value is 1. So we just have a 1 in front of our x squared term. We know that we need to find two numbers whose sum is b and whose product, so product is going to be that c value there. Okay, we apply the acronym SPF, which sometimes you guys see that as PSF, or I know I've taught it and seen it used, they use the acronym MAN, but we're going to apply this idea of sum product factor, and then we use double brackets for each factor. And the way we write our result of our factors is we say x minus s times x minus t, okay, where s and t are the factors that we found. Okay, so we'll go through that process for a few of these. So we're going to factor x squared plus 3x plus 2. So keep in mind, here's your b. We have, this is our b, and then this is our c. So we're going to set up SPF, and it says up top here that we need to find two numbers whose sum is b. So that's what the s represents. So whose sum is a positive 3, and whose product is c. Okay, well my c is right here is a positive 2. That's my product. So we have to figure out two numbers who that satisfy that. So I have to think about my factors of 2 and see if I can make any of those add to 3. Well, the only factors of 2 are 1 and 2. And if I think about that, 1 times 2 equals 2. Let's write that again. 1 times 2 equals 2. And I need those to add together and satisfy the idea of equaling 3. So 1 plus 2 equals 3. So yep, those work. So those are my factors that I'm going to use to break this expression down into factored form. So I'm going to take the 1 and the 2, and they're going to go inside my double brackets. So you're going to have x in one bracket, x in the other, and they're both positive, so you're going to have a plus 1 and a plus 2. All right, pause the video and see if you can try to factor the simple trinomial using SPF. Okay, so there you go. There it is in factored form. We set up our SPF, and we needed to find two numbers whose sum was 1. So just recognize that if we don't have a coefficient, we know that it's 1 there, and whose product is a negative 30. So if we list the factors of 30, we have to see which pair of factors will obviously multiply to 30 but add to 1. And you might have to play around with the sign on your factors to make sure that it adds to the proper sign of your sum. So I knew 6 and 5, I could make that subtract to 1 somehow, but I needed it to subtract to a positive 1. So if I need this sum to be a positive 1, then I needed the bigger factor to be positive for that to happen. So a positive 6 minus 5 will be a plus 1. So we just put those factors inside of our bracket. So you have x plus 6 and x minus 5. And you're all done. One more type of factoring we'll look at today is the complex trinomial. So when we use complex trinomials, this is when a is anything but 1. So that is the different part from the simple trinomial. So a does not equal 1. So we're going to still use this idea of SPF, but it's set up just a little bit differently. So we need to find two numbers whose sum is still b, right? So we still have to add the two numbers to b, but whose product, let's use a different color. So whose product, in this case we have to take into account the a and the c, so it's whose product is a times c. So I'm just going to put a p above that. So a times c, and we'll put an s above our b, okay? So it has to be the sum of b and the product of a times c. And then we'll set up our SPF and go from there. It says we're going to then use these two factors to decompose the middle term into two terms, then factor by grouping. So when it says decompose the middle term, all decompose means is that we're going to break it apart into two pieces. Decompose means to break it down. So if I look at our first example here, let's just move this up. We have 6x squared minus 5x plus 1. So I'm going to set up my SPF. I need two numbers whose sum is going to still be this middle number, which is a negative 5, but whose product is going to be the a and the c multiplied together. So 6 times 1 equals 6. So we need to find two numbers who multiply to a positive 6 but add to a negative 5. So if I think about my factors of 6, I have 1 and 6 and 2 and 3. Now I have to think about that it's adding to a negative number. So we have our factors 1 and 6 and 2 and 3. So they have to add to a negative, but they need to multiply to a positive. So we have to remember that when we are multiplying two things together and they're going to result in a positive, they either both have to be negative or they both have to be positive. So if they both have to be negative, because it adds to a negative, then I'm going to think we need to use 2 and 3. So if we do a negative 2 and a negative 3, that'll add to negative 5, and negative 2 times negative 3 is going to multiply to a positive 6. So now we have our factors. We're going to go ahead and decompose that middle term into those factors. So instead of negative 5x, this is going to become a negative 3x and a negative 2x. But we need to think about grouping them with the terms they're closest to that maybe we can common factor something out of. So I'm going to put with a 6x squared this negative 3x, because I think I could probably then pull something in common out of those two things, and I'll put a minus 2x here. So we brought down the 6x squared and the 1 because we didn't do anything with those, and then we just broke apart our 5x into a minus 3x and minus 2x. So now we can factor by grouping. So from this first group, 6x squared minus 3x, I'm going to common factor out a 3x. So when I do, I'm going to be left with 6x squared divided by 3x is 2x, and a negative 3x divided by 3x is a minus 1. For my second grouping over here, I'm just going to factor out a negative 1. So we don't want to have a negative on our first term there. So if I pull out a negative 1, negative 2x divided by negative 1 is a positive 2x, and a positive 1 divided by a negative 1 is a negative 1. And hopefully you can see now we've created these two terms that have a common bracket that we can now factor out. So I'm going to factor out that common bracket of 2x minus 1, and then you're going to be left with 3x minus 1. Go ahead and pause the video and try the second example on your own, and then I'll put the answer up on the screen. Okay, have a look at the answer here. So we set up our SPF and found our factors to be 1 and 9. Go ahead and decompose that middle term. This time I put my 9d, that one factor, next to my 3d squared because I thought there was something common between those two that I could factor out, and then put the 1d closer to my constant of 3. Okay, I then pulled my common factor of 3d out and was left with d plus 3. The second set here, this d plus 3, there really is nothing to common factor out other than a 1. But we always have to common factor out at least a 1 if nothing else, so that we end up with these two factors at the bottom. So I common factored out a 1, and I was left with 1 times d plus 3. Now I've created these terms that have a common bracket. So we'll just make a note again so we're sure. So I common factor the bracket. And in this case, our common bracket was d plus 3 that we pulled out front. So when we pulled our d plus 3 out, we're left with the 3d in red there, and then the plus 1 from the green there. All right, so that's a good review and look at different types of factoring you're going to have to use throughout the course and in this unit.